All right, so for this lesson, you need your student notes. It's the very first page, so you don't have to really open it up. You need something to write with, and we're going to get going here. But this unit is equations and inequalities. And so there's lots of work within both of these topics. If I look at the big ideas of this next unit, I've highlighted what in yellow we're going to kind of focus on in the first part. One would be equations are two mathematical statements that are equivalent. You're going to see that come up quite a bit in this lesson in the next few ones. And the other one down here, an equation has one solution. All right. So we'll talk about that today and build on it in future lessons as well. Now, an essential question that we're kind of looking to answer along the way here is what process can we use to solve an equation? There are lots of ways to do it, so we're going to kind of give you one prescribed method that helps you solve them, whether it's a simple equation, whether it's a more complex equation. That's where we're going, all right? All right, so let's just kind of get right into it here, solving one-step equations. Well, in order to solve an equation, we must isolate the variable and keep each side of the equation balanced. All right, the goal when solving equations is to get the variable by itself, because if you can do that, it makes it easier to figure out its value. So we call this isolate the variable, all right? One thing that we want to keep in mind here is this word right here. We want to keep the problems balanced. That's why there's an equal sign in there. That implies a balance that needs to happen. The left side is balanced with the right side. So we want to keep that idea always in front of us with the idea of balance. We can use inverse operations to move terms from one side of the equation to the other. We'll discuss inverse operations here shortly if you need a reminder about that. Inverse operations can be thought of as the opposites or undoing operations. I think it's operations. Yes, I was right. So inverse operations are pretty much the opposite operation, all right? And they help us undo certain things in a math problem. So the questions we kind of ask ourselves is what operation is taking place in the problem? And what is the inverse of that operation? Now, inverse operations are pretty simple, and you already know this. I know you know this, you just may not know this word inverse. But the opposite of addition, we know that to be subtraction, because we can very quickly take an addition problem and also show it with subtraction just by moving the numbers around. Same thing with subtraction. Well, the opposite of that is addition. So when we say what's the inverse operation of subtraction, we should know it's addition. Now the same is true for multiplication and division, all right? The inverse of multiplication would be division, and the inverse of division would be multiplication. All right, this is not new. You know that they're kind of opposites, and the same with these two, but we're going to build on this idea today of inverse operations because you need to call upon them and use them to solve equations. And it doesn't matter if it's one step or two step or multi-step equations. You just want to be able to bring these into the problem when needed, all right? So that's the starting point. Let's keep going. All right, now, if I look at these right here, let's just fill in the first blank. Use inverse operations to solve each step below. Actually, there is no blanks. So number one, number two, and number three. Now, I will be very honest. These are some very simple starting points. But before you clock out, before you just assume, I know the answer, it's 4, it's 22. Before you go ahead and quickly do the mental math, let's talk about the importance of learning the steps here, just because things aren't always this simple. All right, so like if I look at the progression of this skill, it does start off with one-step equations. All right, this is what we're focusing on today. You know, you see whole numbers, you see some simple things. Well, I know it's 6. Well, I know it's -9 over here. Well, I know it's 32. All right, so it starts off with one-step equations, but then it builds into two-step equations. And things get a little more complicated. We call these two-step equations because really you have to do two things to get the variable by itself. Like up here, we just had to do one thing to get the variable by itself. And that's what we're going to focus on today. But see the progression. One-step equations lead us into two-step equations. Look at these more advanced problems. And then we've also got these multi-step equations. Okay, now things get really interesting when you're dealing with that much stuff. So just know the progression here. All right, we're talking about one-step equations, but the process we're going through today also applies to two-step equations and a multi-step equation. Okay, my purpose in showing you that was just to give you a glimpse of where things go after a simple one-step equation lesson. This right here is pretty important. You want to learn the steps to solving equations so that later on you know those steps, because you can't always just simply look at these and figure them out mentally. You want to have a method, you want to have an approach that helps you solve for X or for whatever the variable is, because eventually you've got to do these, right? So let's talk about how we use inverse operations to get us there. All right, so back to these right here. Use inverse operations to solve each one-step equation below. Well, the first question we should ask ourselves is, what is happening to the variable? What operation is being performed with that variable? Well, when we see this right here, we know that we're multiplying 4 with the variable. So we're multiplying the variable, and the question then is, what do we do to undo that? And so you ask, what's the inverse of multiplication? Well, it's division. All right, I just rewrote the problem to show it was multiplication. But if I want to undo that multiplication, I do the inverse operation of multiplication, which we know is division. And I divide by 4. Okay, the way to get rid of multiplying by 4 is to divide by 4. And I do it on both sides of the equal sign, though. I do it over here to get rid of the 4. And then I also will do it over here to help me arrive at my solution, because this basically cancels out. That's the benefit of using inverse operations. It cancels out the value of the operation that's performed on the variable. So over there, I'm left with really just the x. But over here now, well, if I divide 16 by 4, I end up with the value of x. So I've isolated the variable, and now I can see its solution. Now, whenever you find the solution, you've always got to plug it back in and just make sure it works. So go back to the problem, plug in what you think the variable is, and in this case we said 4, so really that would be 4 times 4, and that's 16. So it checks, okay, our solution works. X has a value of 4. Number 2, another simple one. I know that's simple, but again, think about the steps here. What is being done to the variable? Well, it's being added to. So you got to think, what's the inverse of adding? Well, subtracting. We want to subtract 9 from both sides, because we want to get rid of that plus 9. And the way we get rid of it is we subtract 9. But you've got to keep things balanced. You got to do it to both sides. That really cancels out the 9's on the left of the equal sign, but on the right, then if I solve that, I'm left with 4. 13 take away 9 would be 4. So that would be my value of x. And again, always double check. 4 plus 9, yes, 13. That's what it is. The third one, another simple one, but again, subtraction. We're wanting to subtract 8 from the variable. So how do we get rid of subtracting 8? Well, you do the opposite. You add 8 to both sides. And that cancels out those. You're left with x. And over here, you're left with 22. So your value of x is 22. Again, we can always plug it back in and double check. But yeah, we end up with 14. So see the process here. You use inverse operations to get the variable by itself. And then you check your work when you're done. Now, I want you to try 4, 5, and 6 on your own. So pause the screen and then unpause it when you are done. You can check your work. All right, number 4, well, you got to think of this as dividing by 5. So the way you get the variable by itself, the opposite of dividing by 5 would be multiplying by 5. Okay, I just rewrote it here to show what's really going on in the problem. So if I want to get rid of dividing by 5, I multiply both sides by 5. And that will cancel out. Now I've got the variable by itself on the left. And if I solve the other side, I end up with 65. So that is probably my solution. I want to double check it. Yeah, 65 divided by 5 is 13. So that's the only value that makes it work. In the next one, you want to get rid of subtracting 6. So you add 6 to both sides. You end up with that value. You should check your work. 17 minus 6 is 11. Yes, now it all makes sense. And number 6, you're multiplying the variable by 2, so you want to get rid of that. So you divide both sides by 2. And you end up with an x value of 44. Again, double check it. 2 times 44 equals 88. Yeah, just go back up to my problem and I plug in what I thought it was just to make sure that it's true. All right, notice the steps here. What we're doing is we're undoing the operation and we're doing it to both sides because we got to keep things balanced. The other thing you should be paying attention to is that we are finding the solution of x. If I go back to one of those big ideas, it was that equations have one value that makes them true, all right? Like 44 is the only one that works here. No other numbers work. 17 is the only one that works here. No other numbers work, and so on. So we're starting to see that pattern with equations, that they have one solution. All right, now it also works though, and you also have to do this with irrational numbers. We started off very simple, but you also understand that sometimes you're going to get into negatives, you're going to get into fractions, you're going to get into decimals, and this is where this lesson really takes a step up, is because it brings a lot of things back into play, a lot of math knowledge. So let's kind of start with this first one, number 7. If I have 6 times x equal to 16, my goal is to get the variable by itself. So if it's being multiplied by 6, how do I get rid of that? Well, I divide both sides by 6. All right, that will cancel out the 6's over here because I'm really left with 1. That would be 1x. But over here, I've got to do that side as well. I've got to do 16 divided by 6. Now, that's going to take me some work. You might use a calculator. You might work it out on paper. You might end up doing it yourself. But bottom line is, if I do 16 divided by 6, I end up with 2.6 repeated, okay? I had to add a decimal point here to my 16. I had to add some zeros. And I see that this is going to keep going because here I had 40 and here I had 40, and I'm going to keep dropping down to 0 and keep getting 40. So the bottom line is I realized this was going to keep repeating. So 2.6 repeated. Now, that's really 2 2/3. I could have also said, 2 2/3 or 2 4/6. That would also have been okay if I wanted to keep it as a mixed number. So decimals or mixed numbers, you can do what you want. But that essentially is your value of x, 2 2/3. All right, so that's what we figured out right here. And we want to check that work. So, I would plug it back in, 2 4/6 or 2 2/3 times 6. And if I work that out, I should get 16. All right, and in this case, I do. This next one up here, if I look at number 8, I want to add 2.5 to the variable. So to undo that, I do the inverse operation of adding 2.5, and that would mean that I take away 2.5 from both sides. Again, that idea of balance. Keep things balanced. What you do to one side, you do to the other. So when I do that, these cancel out, and I'm left with x, which now I've isolated the variable. And on the other side, I end up with 5.0. So x has a value of 5, really. And think about it, $5 plus $2.50 would be $7.50. Okay, so this checks out okay. And you want to prove that, you want to show your work and double check, but that's where you end up. In number 9, if I look at what's being done with a variable, it's being multiplied by 2/3. So the way you get rid of that is you divide both sides by 2/3. All right, because 2/3 divided by 2/3, well, that cancels out now. But over here, I have to now do that. I have to do 8 divided by 2/3. So that's what this right here is showing. And if I take that through, I set these up as fractions. I kind of remember my steps here of keeping the first fraction the same, changing it to multiply, and flipping the second fraction. When I really solve this one, I get 24 over 2, which is really the same as 12. So x has a value of 12. Now, what that would mean is if I plug 12 in here for x, 2/3 times 12 should be 8. And it does turn out to be true like that, because this is my proof. 2/3 times 12 over 1, well, that'd be 24 for my numerators. That would be 3 for my denominators, which this is essentially 8. All right, so I've proved that now. What I want you to do is try 10, 11, and 12 on your own, and then unpause it when you're done so you can see how you're doing with these. All right, number 10, what's happening with the variable is being divided. So we want to multiply both sides by 3. We want to get rid of that dividing by 3. So that's our inverse operation right there. And if I take that further, I end up with an x value of -21. That's what that turns out to be. And if I plug that back in just to double check it, that would be really -21 divided by 3, which is that. And we know that when we're dividing integers and they have different signs, that our answer is negative. So that ends up being -7. At number 11 here, you should have added 1.6 to both sides. You should have got an x value of -6 and 6/10. And you could have double checked it as well. That's a wise thing to do. -6 and 6/10 minus 1 and 6/10 leaves me at -8 and 2/10. Okay. At number 12, we're multiplying the variable by -4, so we want to divide both sides by -4. Pay attention to that negative. You keep it in your inverse operation. Okay. If we do that, we end up with the variable isolated on the left side. -4 divided by -4 kind of cancels out. And over here, -2 divided by -4, well, that ends up really just being a half, and it's a positive half. 0.5 there. It's going off the screen, but you could have done it as decimal form if you wanted to. So x has a value of 1/2, and you could check that just by plugging it back in. -4 times a half. That's the same thing as half of -4. Well, -2 is the result. All right, if you need to pause it and look over those some more, you can. In the next section right here, 13, if a chocolate cake is divided into 6 equal slices and each slice has 280 calories, how many calories are in the whole cake? So let's just start with what we know. We know that there are a couple things here. They tell you, one, the cake is split up into 6 slices, and each slice has 280 calories. We know that. What we need to know is how many calories in the whole cake. So always start off with, what do I know? What am I trying to figure out? Now, the approach that we can use here is just this problem right here. The amount of calories in the cake, think of that as this value right here, the amount of calories in the whole cake, divided by 6 slices means that there's 280 calories in one slice. So if this is my approach to solve this one, now I just want to solve for the variable. Well, again, use inverse operations, multiply both sides by 6, and it will basically tell you that you have that many calories in the cake. So our solution really just is that. The entire cake has 1,680 calories. Now, there are other ways to come up with the equation. This is just one of them, but you could have done something different that also results in figuring this out right here. Okay, if you're not sure if yours worked or not, you can ask me and I can tell you. But there are different equations that you can use. Sometimes people do 280 divided by 6 equals x. Sometimes people do 6 times x equals, they do something like 6 times 280 equals x. There's different things you can do is my point. And so if yours is equivalent to this, you should have ended up in the right spot. That's how you can tell. All right. I want you to try 14 on your own now and see what you can come up with for that one. All right, so in this problem right here, Pedro is making coffee for friends. Here's what we know. We know that he served 34 ounces of coffee and he had 20 ounces left over. So that's the knowledge that they gave us. What we're trying to figure out is how much coffee he made, or specifically, how many ounces he made. Our plan to work this one out This was pretty simple. I just did this. X minus 34 was 20. And if we solve that through, we use our inverse operations to add 34 to both sides. And we're left with 54. So there's your variable's value, 54. So our solution right here, he made 54 ounces of coffee. All right. That brings this lesson to a close. Again, this was just one-step equations with rational numbers thrown in there. We want to be comfortable with this. From here, it goes to two-step equations eventually, and then further down the road, past this course that you're in, you get into multi-step equations in 7th and 8th grade. All right. So that is the end of this video.